Bismillahirrahmanirrahim. Welcome back to my channel. In continuation of our last video about dielectric test of transformer oil, today we are going to discuss its part 2. In part first, we have covered the following topics. Number 1, introduction, where we have discussed why transformer oil matters. Then breakdown voltage test, where we have discussed why dielectric strength is crucial for transformer performance. Now in this video we will discuss testing of transformer oil, where we will see testing method and equipment used, and after that we will discuss result analysis, good, bad, and what to do next. So let us start. Testing of transformer oil, method and equipment used. There are many test standards for insulating liquids, but they are derivatives of three main standards. Two of these are from ASTM International, that is from USA, and other is from IEC Europe. Oil needs to be tested periodically to ensure that it is still fit for purpose. The standard typically defines parameters such as the size, the shape of electrodes, the gap between them, the rate at which the test voltage is increased, how many times the test is to be repeated. These main standards are ASTM D1816 and IEC standard IEC 60156. ASTM D1816 standard is for test method for dielectric breakdown voltage of insulating oils using VDE electrodes, while IEC standard is for determination of the breakdown voltage at power frequencies. High voltage tester and specified test cell play a crucial role in ensuring the quality and safety of transformer oil, as in transformer oil testing is critical for obtaining accurate, reliable, and standardized measurement of the oil's insulating properties. Now we are going to discuss the last part of this series, that is interpreting the results. The results are good, bad, and what to do next. The acceptable breakdown voltage level for the transformer oil depends on whether the oil is new or in service and which standard is being followed. For example, is it ASTM standard or it is IEC 60156 standard is being followed. As our focus is on IEC standard, IEC 60156 uses acceptance values that are contained in two further standards, that is IEC 60296 and IEC 60422. The first standard, that is IEC 60296, this standard is for fluids for electrotechnical applications, while the second standard, that is IEC 60422, is for mineral insulating oils in electrical equipment. This standard prescribes acceptable dielectric breakdown values for new oil and for in-service oil. According to the IEC 60422 standard, first of all we will see the accepted values for the new oil. We will see the equipment voltage and BDV values. For new oil, if equipment voltage is greater than or equal to 72.5 kV, then the dielectric breakdown voltage must be greater than 55 kV. Similarly, if the equipment voltage is greater than 72.5 kV and less than or equal to 170 kV, then the dielectric breakdown voltage must be greater than 60 kV. And finally, if the voltages are greater than 270 kV, then the BDV value must be greater than 60 kV. Similarly, by applying the same standard for in-service oil, here we shall see the equipment voltage and then we will compare the BDV value whether it is in good range, fair or poor condition. The equipment voltage is greater than or equal to 72.5 kV. If the BDV value is 40 kV, then it will be in the good range. If the value is between 30 to 40 kilovolt, then it is in the fair range. If the value is less than 30 kilovolt, then it is in the poor or bad condition. Similarly, this standard also defines the values of the BDV for the equipment voltage is greater than 72.5 kilovolt and less than or equal to 170 kilovolt. You can also find the standard values if the equipment voltage is greater than 270 kilovolt. For reference, you can see the IEC standard 60422 2023 table 5. IEC recommends that if the values are in the fair range, testing should be performed more frequently and the test results should be cross-checked with other testing methods. Similarly, if the test results are in the poor or bad range, the oil must be brought back into a good state by reconditioning. This might, for example, involving the filtering or drying of the oil. Now we shall see how to ensure the long-term transformer health and what are the best practices to do this. Ensuring long-term transformer health requires a mix of preventive maintenance, regular monitoring, and environmental control. A healthy transformer means a higher reliability, longer lifespan, fewer outages, and lower life cycle costs. To do this, following best practices needs to be done. Number 1. Routine oil testing and monitoring for a critical transformer every 6 months, for distribution transformer annually. Number 2. Oil maintenance and reconditioning, filtration, drying or degasification. Number 3. Electrical and mechanical inspection like bushing condition, connection, tape changer inspection, vibration and noises. I hope you enjoyed the video. I thank you for watching. If you want to see more videos, hit the subscribe button. Thank you.